3, 2, 1, go.
Greetings, Earthlings. My name is Orixo, and I come from the planet Terz, wishing to learn about you humans. Thus far, in my brief visit, I have unfortunately learned far too much about the Jonas Brothers, and not enough about how you beings function. I hear murmurs about an incredible system that can control all of the body's processes. My mission is to uncover the secrets of this endocrine system and bring this knowledge back to my home planet.
Watch us be follow Zixo and his quest to understand the complex endocrine system. Let's go, come on, let's go, let's go.
Excuse me, could you please tell me what your endocrine system does?
Ha! Nada!
Excuse me, sir. What do you know of the endocrine system?
Well, basically, it's a system of ductless glands that secrete chemical messengers to regulate bodily functions and maintain homeostasis. It controls processes like growth, heartbeat, and metabolism through use of hormones, chemicals which interact with specific target cells in the body.
I know of pheromones. Are these hormones?
Absolutely not. Pheromones are chemical messengers which interact between separate organisms. Hormones operate only within one organism.
Are all of these hormones the same?
No, there are many different hormones, but they each fall into one of 4 categories: polypeptides, glycoproteins, amines, and steroids. These 4 classes vary in their structure and subsequently how they interact with target cells. For example, steroids are lipophilic, which means they enter their target cells, while amines are lipophobic, which means they bind to receptor proteins on the membranes of their target cells.
What are these glands I hear you speak of?
The glands produce and secrete hormones. The glands are
The hypothalamus. I'm the control center.
The pineal gland. I make melatonin to control sleep patterns.
the pituitary gland. I make growth hormone, oxytocin, antidiuretic hormone, prolactin, follicle stimulating hormone, luteinizing.
The thyroid gland. I make thyroxine to control metabolism.
I'm the parathyroid gland. I control blood calcium levels.
Where are the adrenal glands? We make adrenaline.
And the testes, I make androgen.
The ovaries! We make estrogen!
Hey, Teach, I have a question. Okay, so I understand that hormones are released in response to internal or environmental stimuli, but what's there to stop these hormones from being released too much?
Excellent question, Halfway. The body needs to regulate its production of hormones so they aren't overproduced. The endocrine system accomplishes this with a series of negative feedback loops, or cycles in which hormone-induced responses regulate the stimuli or stimulus that caused the response. Let's use an example that begins with the hypothalamus, as it is the control center of the endocrine system. So, we have your hypothalamus. The hypothalamus produces a hormone called TRH, or thiotropic-releasing hormone. After being produced in the hypothalamus, TRH travels to the anterior pituitary gland and stimulates the production of another hormone called TSH, or thyroid-stimulating hormone. Here you have your anterior pituitary, which produces TSH, thyroid-stimulating hormone. So far, so good? Okay. Now, after being produced by the anterior pituitary, write that in there, TSH travels to the thyroid, where it secretes the production of thyroxine. Put the thyroid over here. Oops. Red's not working. There we go. Now, thyroxine is a hormone involved in many essential functions, including regulating heart rate and blood pressure and the development of the skeletal and nervous system. But its most important function is maintaining the body's basal metabolic rate, or the minimum energy expended to perform basic functions like breathing and digestion. Concerning negative feedback loops, thyroxine inhibits the formation of TRH, which means when thyroxine is produced, it checks the production of TRH, subsequently checking the production of TSH and limiting the production of thyroxine itself. Therefore, the body can maintain homeostasis and not produce too much thyroxine.
Wow, Teach. So the production and secretion of hormones essentially checks itself? That's ingenious.
I'm trying to sleep here. Hey, whoa, calm down, Oscar. Why are you sleeping in the middle of the day anyway?
I'm tired. Sleep all the time.
You know, he hasn't been rushing lately.
How long have you felt this kind of fatigue?
I don't know, a while.
Yeah, you're losing your hair too. You're alright.
No, I'm not.
Yeah, maybe.
So what?
How's your appetite been lately, Oscar?
Fluctuating. It's there and it's not there. I'm hungry.
Oscar, you look like you're gaining weight. Is your metabolism going up?
Maybe, I don't know.
Sounds like you have hypothyroidism, Oscar.
What? The word of the day is hypothyroidism.
Welcome to the extraordinary match between the two fiercest fighters in the business. Insulin and glucagon. You don't want to miss this. Yo guys, wait till the fight, wait till the fight. It's sure to be an epic clash between these two titans. Before we start, let me take an interview with the two companions. So, Insulin, where are you from?
I come from the beta cells and the islets of Langerhans.
That's in the pancreas, right? So, could you briefly explain your role in the endocrine system?
Well, basically, my job is to lower blood glucose levels. When there's too much glucose in the blood, I spring into action to make cells that store excess glucose as glycogen in the liver and muscles and fat in adipose tissue. At the same time, I slow the breakdown of glycogen into glucose.
Wow, that's interesting. What would happen if you weren't there to do your job? Now speak up, it is so loud!
Cells need glucose for glycolysis, the first step in cellular respiration. Without me, organisms would become diabetic. That is, their cells can't take up glucose quickly enough to meet their metabolic needs. Instead, they can only break down fats, which can lower blood pH and deplete ion concentrations.
Wow, Insulin, thank you. Where do you hail from, glucagon?
I come from the islet of Langerhans.
Did you grow up near your opponent?
Nah, I grew up in the alpha cells, repping the big A.
Now, once again, glucagon, it's really loud in here, so I need you to speak up. Hold on one sec. How do you maintain glucose homeostasis in your body?
Well, I pretty much keep insulin in its place. When blood glucose levels become too low, I head over to the liver and make him hydrolyze glycogen, which restores the level of glucose in the blood.
Interesting. What similarities do you have between you and your opponent?
Well, we're both lipophobic polypeptide hormones, so we perform signal transduction in a similar fashion. We both interact with our target cells by binding to receptor proteins on their membranes and using second messengers to relay our stimuli inside, where they induce our desired changes.
Thanks for your time, glucagon, and good luck!
Thank you.
Fighters, let's get ready to rumble!